In this example, we're going to look at conditional probability. Conditional probability is based upon an event that probably occurred, and there's additional information about that other event. And what that means is that the second event depends upon what happens to that first event. The formal rule for conditional probability states that the probability of B given A occurs, and that's what this vertical line stands for. It's given that A occurs. You can actually calculate this by taking the probability of A and B together, and this is using our multiplication rule, and then you can divide it by the probability that A occurs all by itself. I don't actually want you guys to use this formula. I want you to think about probability, conditional probability, intuitively by looking at a chart. Here I've created a pretty simple and straightforward chart, and let's say that we have some potential people that are infected with COVID-19. Over here I have infected people, and then I have non-infected people. And then I also have given the COVID test where they test positive for COVID-19, and then they test negative for COVID-19. And let's ask the question, what's the probability that someone is infected given that they had a positive test? The fact that they're given that they have a positive test means that we're not interested at all about the ones that actually tested negative. So all we have to do is simply cover up that part of the chart that we're looking at and then calculate our probability from there. So I'm going to cover up the ones that actually tested negative here, and I'm only going to consider this part of the chart. Here we have a total of, 8 that tested positive and 6 that had actual COVID-19. So our probability is going to be 6 divided by 8. Let's invert this and see what happens. Let's take the probability that someone was positive given the fact that they were infected. Now you may want to be able to, you may think that you want to put down the same fraction, but that's not entirely true. What we will do now is we're only interested in the ones that are actually infected, because remember, this says it's the probability of somebody tested positive given that they were already infected. So we're going to cover up the ones that weren't actually infected. So we're going to cover up this part of the chart. Okay, so we had 7 that were infected total, and we had 6 of those that actually tested positive. So now we're going to have our probability is going to be 6 divided by 7. Thinking that these are the same outcomes is called confusion of the inverse. And we want to make sure that we don't confuse the inverse when we flip these things over.